You're about to see how Alpha1 AI teaches students.
Hey, Chloe, can you hear me?
Yes, I can hear you perfectly.
Chloe, I am in a Texas high school pre-calculus class today. Would you introduce an exponential function and their graphs on the whiteboard and also draw a clear coordinate plane diagram showing transformations? I would like to see example of growth versus decay. And lastly, on the whiteboard, introduce logarithms as inverse. Draw the reflected graph across y equals to x, and then I can use that to teach the class.
Let me walk you through what's appearing on the board. First, on the top left, we're showing exponential growth and decay. Exponential growth, like y equals 2x, curves upward faster as x increases. Exponential decay, like y equals 1/2 x, decreases quickly as x increases. On the top right, you'll see transformations of exponential functions. We have the original y equals 2x, a vertical shift up by 3 units for y equals 2x plus 3, and a horizontal shift to the right for y equals 2x minus 2. Finally, on the bottom, I'm showing how logarithms are the inverse of exponentials. We've got the exponential function y equals 2x and the logarithmic function y equals log 2.
Hey, Chloe, can you hear me?
X, which is its reflection across the line y equals x. Let me know if you'd like me to add any specific labels or adjustments.
No, this is very helpful. So if we can go to one at a time, especially the exponential transformations, can you explain to me why the orange line is the inverse, but it looks very different than the green line?
That's a great observation. The orange line represents the logarithmic function, which is the inverse of the green exponential line. Because they're inverses, the orange line reflects the green line across that diagonal line y equals x. They look different because the exponential function grows really fast, while the logarithmic function grows much more slowly. Each point on the green line corresponds to a point on the orange line, just flipped across that diagonal.
Okay, and then could you explain the bottom piece where I have these blue lines and the red line? If you keep growing, would they grow like the black line, y equals to x, as long as they can be stretched more on a graph?
X, which is its reflection. That's a great question. The black line y equals x is a straight line, and it represents where both the input and output are equal. Now, exponential functions and logarithmic functions never actually grow like that line. Exponential functions grow faster and faster, so they'll never just be a straight line like y equals x. Logarithmic functions, on the other hand, grow slower and slower over time. They keep increasing without bound, but at a decreasing rate, so they'll also never just look like a straight line but keeps going evenly upward. In short, both exponential and logarithmic functions grow in their unique ways and will never just match that steady growth of the line y equals x.
Ah, that makes sense. So is it safe to say in the bottom graph that the blue line is a exponential line and the red line is the logarithmic line?
Yes, that's exactly right. The blue line represents the exponential function and the red line represents the logarithmic function. Because they're inverses, the red line is basically a mirror image of the blue line across that diagonal line y equals x. It's safe to say that whenever we have an exponential line, its inverse will be a logarithmic line. They always come in pairs like that.
Perfect. Thank you.
Learn more at alpha1ai.com. Follow us on Facebook, Instagram, X, TikTok.